Welcome. In the world of AI, building robust systems goes beyond just model accuracy. It's about how your application adapts to different contexts. Today, we're diving into a crucial aspect of system design: environment configuration. Imagine your AI quiz platform needing to behave differently, whether it's under heavy load in production, undergoing rigorous testing, or being actively developed on a local machine. That's the power of effective environment configuration. By the end of this lesson, you will be able to understand the necessity of environment-based configuration, learn how to implement a hierarchical configuration system, and identify best practices for secure credential management. We'll also explore how to apply environment-specific settings for critical AI integrations and databases. This knowledge isn't just theoretical, it's what separates hobby projects from scalable, production-ready AI applications. Let's get started and equip you with the skills to build truly adaptable systems. Think about large-scale platforms like a major social network or a global streaming service. They run the same core code base across thousands of servers, yet each environment, development, testing, and production, requires distinct settings. For instance, your development environment needs verbose logging to debug issues and might use a simple local database. But in production, you demand optimized performance, minimal logging, and highly secure credentials. Consider your AI quiz platform. In development, you might want to unlimited API calls to test your Gemini AI integration freely. In production, however, strict rate limits and more robust models are essential to manage costs and ensure consistent user experience. This challenge is avoiding hard coding these varying settings directly into your application. Hard coding leads to brittle systems, security risks, and a nightmare for maintenance. A dynamic configuration system is paramount for both flexibility and security, allowing your system to adapt without changing a single line of code. This is where robust environment configuration truly shines. So, how do we build a system that handles these dynamic configurations gracefully? The answer lies in a hierarchical override mechanism. First, our configuration system starts with a set of base configurations, acting as sensible defaults for everything. Then, environment-specific files like production.json or development.json come into play. These files override only the necessary values from the base configuration. The final and most critical layer is provided by runtime environment variables. These variables are typically used for sensitive data, like API keys or database credentials, ensuring they never enter your version control system. The system loads these configurations in a specific order. First, the base.json, then the environment.json file, and finally, any runtime environment variables. This structured approach guarantees that your application gets the correct settings for its current environment, maintaining both flexibility and security without ever exposing secrets in your codebase. Let's look at how this plays out with crucial integrations like databases and AI services. Each environment often requires a different database connection strategy. For development, you might use a simple SQLite database for ease of setup. Testing could leverage PostgreSQL with automated cleanup scripts for isolated data. But for production, you'll likely implement robust connection pooling, possibly with read replicas, to handle high traffic and ensure data integrity. Similarly, your Gemini AI integration needs environment-aware settings. In development, you might allow unlimited API calls and use cheaper, higher latency models for rapid testing. Staging environments might introduce reasonable rate limits. However, production demands consistent AI performance, often requiring stricter quotas, faster models, and fallback mechanisms to ensure your users always have a smooth experience. This granular control over integrations is vital for managing resources, costs, and performance across your entire system lifecycle. Beyond flexibility, security is paramount, a non negotiable rule. Never hard code API keys or sensitive credentials. Our system relies on environment variables for secrets. In development, you might use .env files, which are explicitly excluded from version control. For production, these credentials should be fetched from secure vault systems like Kubernetes secrets or cloud-native key management services. A robust configuration system validates all required environment variables at startup. If critical credentials are missing, the application fails fast, preventing potential security vulnerabilities from surfacing later. This isn't just theory, it's a practice adopted by major tech companies. A large music streaming service, for example, manages configurations for hundreds of microservices using similar patterns, pulling sensitive credentials from secure vaults. By implementing these enterprise-grade patterns, your AI quiz platform is prepared for the rigorous demands of real-world systems engineering. To check your understanding, what are the key benefits of using environment variables for sensitive data instead of hard coding them?